Welcome to MEI Numerical Methods Solution of Equations 2. In this video we'll be carrying on looking at the fixed point method. Now this is the rearrangement of f of x equals 0 that we found in the previous video that produced a convergence sequence of estimates of the root. And it can be shown that the thing that determines whether the sequence converges is whether the gradient of the curve at the actual root is, if it's less than 1, as in this case where we've got the curve intersecting with y equals x, so that's represents the solution of the equation. We can see that the green line has got a positive gradient and its gradient is less than 1 because the gradient of the red y equals x line is 1. So we can see that that condition is satisfied, and we'll be looking at another example shortly where the gradient's negative, and in that case it has to be greater than -1. Now this convergence can be demonstrated graphically, and we've got a starting point of x equals 1 here, and this is the graph of y equals g of x. So we're first of all going up to the graph there. So we started with x naught, so x naught is 1, and then we're finding g of x naught, and then we're going across the line y equals x, and the idea is that the x coordinate of that point will be the same as the y coordinate of that point. In other words, x1, which is down there approximately, is going to be g of x naught, and then the process just repeats itself. So we go up to the curve again, and then along to y equals x, so that x2, which is about there, that has the same y value as this point here, which was g of x1. And so that obviously carries on until, assuming we've got an appropriate gradient for g of x, everything converges on the intersection of y equals x and y equals g of x. And this is an action version of the previous diagram. So we went up to the curve, along to y equals x, up to the curve again, along to y equals x, and then we're converging on the intersection of y equals x and y equals g of x. Now, to illustrate the case where the gradient's negative, we've just slightly tweaked our function so that we've got plus x there instead of a minus x, and this produces a new rearrangement. So we'll just check that that works. We've got x cubed plus x minus 1 equals 0, and adding 1, subtracting x from both sides gives us that, and then if we take the cube root, that gives us g of x there. And we can see from the graph that g of x it's got a negative gradient at the point of intersection with y equals x, and it's negative, but it's not as big as in absolute terms as as -1. In other words, it's greater than -1, and obviously it's less than 1. And it's not quite as easy to see that it's greater than -1 this time, but we can, by looking at a line that's perpendicular to the line y equals x. Obviously we're looking at doing that down here, and you can see the green line is not quite perpendicular to the red line. Now we can demonstrate the convergence graphically in this case as well, and it turns out that we don't get convergence if we start at 1, but if we start at 0.2, for example, then we go up to the curve as before. So that's got a y coordinate of g of x naught, and then if we go over to the line y equals x, so that's where we're calling that x coordinate x1, and that's the same as its y coordinate, which is the same as the y coordinate of that point. So x1 equals g of x naught, and then we go down to the curve again. So the y coordinate of that point is g of x1, and then when we go over to the line y equals x again, the x and y coordinates are the same, so the x coordinate, which we're calling x2, is going to equal the y coordinate of that point, which was g of x1. And then the process just continues, and because of the favourable nature of the gradient, namely that it's greater than -1 and clearly less than 1, that ensures convergence. So in this case we've got a cobweb pattern. Previously we had a staircase pattern. So that was the staircase pattern there. And here we see the cobweb pattern in action. That concludes this video on the fixed point method. We'll be looking at convergence in more detail in a later video, and we'll be looking at other aspects of the fixed point method in the next video.